Hello, ladies and gentlemen, and welcome to the Science Gym Show. My name is indeed Science Jim, the one and only. So, hello. Today, what I want to do is talk a little bit about nuclear power, and specifically nuclear power plants. We may revisit this later and talk more about radiation and stuff, but today I want to talk more about nuclear power plants. They've been in the news a lot lately, for better or for worse, and I just want to kind of make sure people kind of have an idea about what it is that we're talking about, all right? So, let's go there. Let me first of all take this over here and shrink myself. Hey, I'm shrinking. Help me. All right, move this over here. All right, and go from there. So, sciencegym.com, kerclick.com. You can get more Science Gym stuff there. Okay, advertisement over. Here we go. The reason why we need nuclear power is because we need electricity. You're watching me because of electricity. Your lights are on. You have hot water in the shower. You can perhaps cook your food because of electricity. Electricity is key, and we're using more and more of it all the time as we're making more different types of technology and things. We're using more electricity all the time. We may soon be driving our cars using electricity, either partially or fully. So electricity is key to being human. Well, if we're going to use all this electricity, we got to get it. There's three basic ways to get electricity, at least in the United States. The three basic ways are, upper left-hand corner here, is the coal burning, and that's the way we get most of our power here in the United States, is by using coal, which is locked in the ground. We dig it up, basically set it on fire. We'll show you later how to make electricity out of coal. Natural gas is the one just to the right of that one. And then down below we've got nuclear. In the United States, about 20% of our power is nuclear energy. Some states more, some states less, but about 20%. Why is there a hamster in a wheel? Well, believe it or not, all electricity, except for solar power, comes from spinning wheels. Whether it's nuclear, coal, natural gas, wind, geothermal, all comes from some wheel spinning somewhere. Now, usually it's not a hamster. Usually it's something more like this. This is a steam-driven turbine. And basically what these steam-driven turbines do is steam makes them spin. Believe it or not, just like your teapot. If you were to take a teapot and take one of those spinning whirligig things and hold it over the teapot and make it spin, that's the basic fundamental way to make electricity. Now that's spinning something that's spinning because of the steam. It's spinning. It's usually attached to a huge rod, which is attached to a power generator. What that power generator basically does is it either spins a magnet around a wire or spins a wire around a magnet. That's it. That's how to make electricity. Believe it or not, that's all there is to it. That's easy. The hard part is getting the thing to spin. Where's that going to come from? Well, basically, except for solar power, we get that from steam. We boil water. Coal boils water, natural gas boils water, nuclear boils water. This rock is uranium. Uranium is a radioactive rock, which means it gives off particles. It breaks apart all by itself. And as it breaks apart, it hits other rocks. Well, the atoms break apart, what breaks apart hits other atoms, which breaks them apart, which hits other atoms, which breaks them apart. And we have this chain reaction. This picture right here. This chain reaction basically makes heat. When it comes to making nuclear energy, we don't really care about the chain reaction, except that it causes heat, which we want, but it also causes radiation, which we really don't want, and that's the dangerous part of nuclear energy. But we do want the chain reaction because every time it breaks, it releases heat, and it releases a lot of heat. Here's a stat. 1 pound of uranium, 1 pound of uranium, highly enriched uranium, is equal to 1 million gallons of gasoline. The power in 1 million gallons of gasoline is equal to the power in 1 pound of uranium. Nuclear power is extremely powerful, extremely compact, wonderful source of energy, except for that whole radiation thing, a bit of a downside. But nuclear power plants, on the whole, are extremely safe. We'll get to that in a while. Here's a nuclear power plant. You can see these two huge concrete barriers. They look like big, like ice cream cones, kind of upside down, right? All right, these two huge concrete barriers. That's where all the action happens. Let's go inside and take a look. This is a picture that I took from howstuffworks.com. They've got a great article on this and some of the best pictures on the web, so I borrowed several of them. I hope they don't mind. So you can kind of see the picture of the nuclear power plant. Let's go inside and take a closer look. This is where it all happens. This is the core, okay? If you take a look at your handy-dandy little picture down here, you can see what's called these, see the pellet, kind of the lower middle? The pellet is a little bitty, almost like the size of a battery, a AA size battery, a little smaller, a little thicker, size piece of uranium. They take this uranium and they put it in these rods. It's called a fuel tube here. They put it in these rods and they have these long rods filled with uranium. Okay. Now, the other thing they have is not just those rods, but they've also got control rods. The uranium splits. Pew, 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 pew. Pieces everywhere, heat everywhere. As long as it keeps splitting, it can cause more splitting and more splitting and more splitting. We have a chain reaction. The control rods help to suck up that energy. And in fact, if the control rods are put all the way in, it sucks up all the energy that's being released from these splitting atoms and causes the reaction to shut down. The problem is, still make heat. That's where the other stuff comes from. Here's the containment vessel. Look at the big dome. That's that big concrete dome we saw in the first picture a little while back, right? Okay. That big concrete dome is filled with all kinds of steel and all kinds of safe stuff, and these things are built to withstand earthquakes. And in the recent one in Japan, it worked. It wasn't that this broke. What broke was the power. The wave came in, washed away the power, washed away the generator, which took away the water, which we'll talk about in a second. Okay? So it withstood the earthquake. It was the tsunami that caused the problem, right? But take a look. You can see the core, those rods sitting in there. They're sitting inside water. The water is pumped in through one side and pumped in through the other side. The water pumped in through one side is cool water. The water pumped out through the other side is hot water because it's taking the heat away from that uranium, that nuclear process. Now take a look what this tube goes into. It goes into basically a big bucket of water. This is the steam. Remember the steam, the teapot, the hamster? Here we go. Here's a slightly closer picture. You can see the core in there, the water coolant. The water acts to cool things down so things don't overheat. If things overheat, we get the problems, perhaps explosions, perhaps the Chernobyl thing that happened way back when, although that was a complete mistake and nuclear power plants aren't made that way anymore. That really can't happen anymore. But you can still have problems like we're having with Japan. So now you can kind of take a look here. We've got the spinning wheel. So take a look. Unfortunately, the picture is poor, but that pipe goes up and out of the picture, and then back down over here. Here's our spinning wheel, the dynamo, if you will, okay? The steam spins the dynamo. The dynamo spinning causes the generator to spin, and it's that generator spinning that causes the electricity, okay? Last but not least, we get to the cooling tower. The cooling tower, if you live anywhere near a nuclear power plant, you've probably seen these. These are the pictures with all the big stuff coming out the top. Well, believe it or not, what's coming out the top is just water. It's the same kind of stuff that comes out of your teapot. It's just steam. Nothing dangerous. All the radiation is locked up inside those cooling towers, inside those containment vessels, and in fact, inside containment vessels, inside the containment vessels. Radiation doesn't get out of these things. Water, however, does. There's the whole shebang. I will post this link on my website next to this video so you can take a closer look at this and really examine it more closely. But from the hot tubes, boiling the water, spinning the wheel, creating the electricity out through the wires to perhaps your house, your computer, you listening to me on your speakers, ladies and gentlemen, that is nuclear power. Thanks so much for watching, ladies and gentlemen. Enjoy the Science Gym Show. Be sure to check out sciencegym.com for more Science Gym shows and more goodies all the time. Bye-bye, everybody.